works. Oh yeah, it works. Hello everybody. Okay, I will just start the presentation and just want to give you a brief overview of the BeiDou-3 constellation, which is the global phase of the development of the BeiDou constellation. And just to make you aware how major it is, we have 26 MEO satellites, 4 GEO satellites, and 3 IGSO satellites. And I will focus mostly in the presentation on the MEO satellites. So we have 10 satellites manufactured by Shanghai Engineering Center for Microsatellites and 16 by China Academy of Space Technology. And within the second group of satellites, like the metadata that was provided by the BeiDou authorities, differentiate between second A and second B satellites, which have different dimensions because second B satellites are equipped with search and rescue payloads. And official metadata files specify that there is only one type of BeiDou CAS satellites, but we know that 4 CAS satellites are equipped as well with search and rescue antennas. And thanks to a tremendous effort of IGS and collaboration between IGS, ILRS, and BeiDou authorities, in January 2023, ILRS started to track all the satellites, all the BeiDou-3 satellites, because till 2023 only 4 of these were tracked. And I just want to give you a kind of summary of the first year of tracking. So why do we need these observations? Because I suppose that IGS community wishes to incorporate BeiDou into future releases of global terrestrial reference frames, as we did with Galileo for ITRF 2020. And the previous studies of the individual BeiDou-3 MEO satellites show us that orbit modeling is quite challenging, especially solar radiation pressure modeling. We already seen in the presentation given by Florian. And we may distinguish more groups of satellites, that this was also mentioned, based on the patterns in the SRT model parameters and or estimated satellite phase center patterns. So satellite laser ranging SLR was crucially required for performing SLR orbit validation and enhance our understanding of the system, particularly regarding orbit modeling issues. So what about the tracking performance of the ILRS network? This heat map shows the number of normal points collected by ILRS network for individual satellites. For BeiDou-3 satellites and Galileo satellites, just for reference. And with these red bars you see, in ILRS we have something like priority satellites. So these are the satellites which are prioritized by ILRS to be tracked. And the priority satellites have 2 times more observations compared to the other BeiDou satellites. And the stations provide almost 2 times more observations for Galileo than for BeiDou satellites, for the non-ILRS priority satellites. And if you have a look here, here the increased number of Galileo observations at the beginning of 2024 arises from the ILRS support to Galileo for science project, but it didn't affect the number of BeiDou observations. So ILRS can track more. SLR stations rely on orbit predictions, and here I just presented the availability of these predictions and the quality. Those are provided for ILRS by Shanghai Observatory, and for the quality, these are compared with CODE MJEX final orbits. So for the availability, the average time between successive releases of these new satellite predictions files is approximately 3 days with occasional intervals of 5 to 10 days. And the thing that you should notice here is that there are no predictions for C27 and C28 from the beginning of March 2023. And I discussed this matter with ILRS station operators, and they failed to get returns from either satellite despite these predictions. And so that Shanghai Observatory just stopped providing these predictions. And the prediction quality reaches 10 to 100 meters, which is quite poor, but we found no correlation between the prediction quality and the number of observations. So we did the SLR validation of the orbits provided by all ACs that I am aware that provide BeiDou-3 orbits. So CODE, ESA, GFZ, Wuhan, EAC, and Shanghai. And before diving into details of the results, let me just summarize the orbit modeling options as adopted by different ACs. I mostly focus on the orbit modeling options. So these products differ in terms of the way that they handle SRP. So we have different set of empirical parameters estimated, these are here, and different arc lengths, or the usage of a priori box wing models, and the source of the coefficients used for this boxing model is also like unknown or known, but we know that there are some groups providing these coefficients, including of these official ones, but there are some also empirically adjusted. So now let's move on to the results, and I will just firstly focus on one AC, which is coded, and here we have the box plots of SLR residuals for individual satellites. We clearly see the two groups of satellites, so the cast satellites on the left and second satellites on the right. And the mean SLR residuals is at the level of minus 50 millimeters for cast and minus 20 for second. And we can also notice that the box plots are quite consistent in pairs, and these are the pairs of satellites which were launched together, and these are the most consistent. And we see what was also mentioned before in one of today's presentations, that we see more groups than the metadata indicates. And let me go back to the analysis that we did like 2 years ago, and this figure shows the coefficients of the econ model as estimated in 3 different orbit solutions. One of those in red is based solely on econ model, and 2 of these with econ parameters estimated on the top of the 2 different box-wing models. And we grouped, these are different econ coefficients and are presented as a function of beta angle, and we grouped the satellites by the common patterns in the estimated econ parameters. So the key message here is that more different groups of satellites which are placed on a given orbital plane and are characterized by similar pattern in the estimated econ parameters. So let me merge these two slides, and I just added the identified groups here, and the groups details from the analysis of empirical parameters are indeed reflected in the different distribution of SLR residuals. For example, these 4 satellites here are the cast satellites with search and rescue payloads, and we have also these one pair of cast satellites and 1 pair of second satellites, which are marked with asterisks. So I grouped the satellites with the types that I indicated and performed the SLR validations of all the ACs, and the first we can see is that the different modeling of BeiDou-3 orbits are implemented by different ACs, results in large differences in the outcome of SLR validation. And this is the problem that we need to face in the near future. But if we compare the standard deviation of SLR residuals, which is kind of measure of quality of these orbits, and compare the ACs, so for the nominal types of BeiDou-3 satellites, so the cast second A and second B, the standard deviation is at a comparable level with Galileo FOC. Okay, let's dig any deeper. And this is the decomposition of SLR residuals as a function of the latitude of the satellite with respect to the latitude of the Sun and the beta angle. So this is the elevation of the Sun above the orbital plane, and different rows are different subtypes of the cast satellites, which I indicated some slides before. So I selected only 3 ACs with the base results, and the orbit modeling deficiencies are visible for most ACs and subgroups of satellites. And ESA orbit modeling works great with BeiDou-3 cast satellites, which is comparable to their Galileo FOC results. We also seen this from today's presentation given by Florian. And our SLR residual analysis confirms the validity of grouping satellites, revealing differences in orbit quality and systematic errors. The same kind of analysis, but for second satellites. Again, we select only 3 and different rows different roles refer to different subtypes of identifying second satellites. Again, ESA orbit modeling works great with BeiDou-3 second A satellite, and we see also the largest scatter of residuals here, which applies only to high beta angles, and these are satellites on plane C. These are C25 and C26. And the last thing that I want to raise today is the improvement of metadata for C43 and C44, because this is the plot we showed, we presented in the last paper. Then we identified large scatter in the SLR residuals for these two satellites and indicated that it might be it might origin from the errors in the metadata of the official LRA X and Y offset from the BeiDou metadata. And in the meantime, our colleagues from ESA and DLR estimated these values and validated these, and eventually the CSNO updated the values, which are really close to these estimates, independent estimates. And after that, the RMS of SLR residuals has been reduced from 150 to 20 millimeters. So, conclusions. The ILRS network successfully tracks almost entire BeiDou-3 constellation, because as I mentioned, as of March 2023, ILRS networks observes 22 BeiDou-3 satellites instead of the full 24 due to the suspension of orbit predictions provision for C27 and C28. SLR validation revealed more satellite groups in the BeiDou-3 constellation than documented in official metadata, and the current orbit modeling works well for 16 out of 22 BeiDou MEO satellites, and improving modeling for the remaining satellite is a challenge to be faced. Regarding ILRS support, the continued ILRS network support and increased observations for specific satellites are recommended to improve orbit modeling, and the current ILRS recommendation is to track 4 satellites, and personally I would recommend to focus on one for all these types that I identified, and this is something to be discussed with ILRS network and engineering standing committee. Thank you for your attention.